Hello, this is the next video in a playlist that I'm calling Parameter Estimation, and it deals with normal unbiased estimators and how if we're in that setting, that implies that the mean absolute loss is proportional to the square root of the mean squared loss. And since many of our estimators will be asymptotically normal and unbiased, it shows that using mean absolute loss is proportional to the square root mean squared loss. And we're going to point back to this video when we get into some of the asymptotic properties of our estimators. So our estimator we're going to call Thetahat, which is a function of our sample or our data, and sometimes we'll write it in vector notation, but to slightly abuse the notation we'll often just call it Thetahat. But Thetahat is really a function of our sample. By assumption, Thetahat is normally distributed with mean theta and variance sigma squared. How do we know that the mean is theta? Well, by assumption we're assuming that this is an unbiased estimate, so on average it equals theta. And that's what this means. Now if we subtract theta from our estimator, then it's normally distributed with mean 0 and variance sigma squared. Now if we take the absolute value of our estimator, then it's what's called a folded normal distribution with mean 0 and variance sigma squared. And since the mean is 0, it's actually probably better called a half normal distribution. I have a video called the mean and the variance of a folded normal distribution, and when I put this out I didn't have a video on the half normal, but 2 days ago I put out a video on the half normal. So I have two videos, and it's called mean and variance, and then one is a folded normal distribution and the other is a half normal distribution if you want to see a little bit more about these distributions. So if we let y equal to this absolute value of this difference, it's what's called a half normal distribution, or folded normal, but the specific case is half normal. So the density is this, and we derive this density in both the videos on folded normal and half normal. So this is the density. So now let's look at squared loss, and that is the loss function is this. So it's the difference in our estimator versus the parameter we're estimating squared. And since Thetahat is unbiased, this theta is actually equal to the mean of our estimator, right? Because this is theta. Now we want to take the mean squared loss, sometimes called the risk. So the mean squared loss is this, and then we plug in here. But this is the formula for the variance of sigma or of Thetahat. So it's just the variance, which we know is sigma squared. So that's squared loss. Now the absolute loss is this. You just take the absolute value of this difference, and we want to look at the mean loss or the risk, which is this, and then you plug in what the loss function is. But we know that this is a half normal distribution, or distributed with a half normal, and the mean of a half normal is this, right? So so then this is the standard deviation, this is the constant, but I actually forgot to take the square root of that. So this loss function is proportional to the root of the mean squared loss. And again, we're going to point back to this video when we get into some of the asymptotic properties of these estimators. Well, I hope you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.